Hello. So this video is to show you how to use the repository. So when you go to GitHub, here you have the overview, and they are basically for training. There are different libraries. In our case, we can use three in Isaac Lab, but we will focus only on the SKRL one. So then in the scripts, SKRL train, you have the training script. As a task for now, I have created only this post tracking where the goal is to teach a quadrotor to hover at a specific position with some given heading. And then there are some documents that you can create. Right now, I think the documents are updated, but I have removed some of them just so that you know. And then when it comes to the local installation, you can just use this link, and then here there are four sections to install it locally. Follow this one, where basically you need to download Isaac Sim and install it. And then once you have installed it, then you can clone Isaac Lab repository. You need to create some virtual environment for that, and then you do this install. So it's only a few steps, but if you did them carefully, it should be fine to install. And then once Isaac Lab is installed, you can do this command to test that it's working properly. So those are the steps to install Isaac Lab. I also put them here, shouldn't be a big problem. And then you also need to install GitLFS so that you can get the role model. And once you have this, then you can clone this repository. To create a virtual environment for this repository, you go to Isaac Lab, and then you do this. So you create the virtual environment there, and then when you come to our repository here, you just need to use the virtual environment that you created there. This is how it works. And then you need to add this path to the Isaac Lab in the current directory, like for the repository, so that it looks back at the Isaac Lab, and then it can get some stuff. And for training, all the weights and all the models, all the artifacts are also uploaded to Weights and Biases. So yeah, it's optional. You can also use debug them locally, but it's quite useful if you can directly upload them to Weights and Biases to also see all the plots. So I will also give you, like, once you run the trainings, maybe it's easier, you will see something like this. So this is position tracking command in RL velocity, and this is command in RL rate. So usually you record some videos during training. To activate them in the configuration, you need to pass this video flag, and then you specify every how many frames you want to save the video and how long the video should be. And then you will see something like this, where this is the reference where you want the drone to be at, and then the red axis is the x-axis. And so if you want to follow the heading, yeah, it should be pointing like that. And then you will see rewards for the different types of rewards that there are, some rates that you can check so that the training is working properly. So for example, if you want to follow the position, then you should see that the position in the error gets lower with time. And apart from that, yeah, instantaneous rewards, I mean, this is the total, not the specific ones. And you will also see information about the system, like the frames per second, the steps per second, etc. And right now I'm training with 2000 environments. If you run out of memory, you can use less. And in the repository, you also have some, like, idea of what you do. So for example, once you install it, the repository looks like this. In the scripts, SKRL train is the main script to run for trainings. And then in source, there is Isaac Pursuit Evasion. In assets, there is a Crazy Fly bracelet, so you should see these files, and also this class function, which defines the bracelets. For controllers, there is a Crazy Controllers, which basically implements the same controller that there is on board of the Crazy Fly, so you can also take a look at it. And then the RL controllers. which implement the velocity and the body rate-based controllers. And in Isaac's procedure version, in task, there is a post tracking, and usually there is an environment configuration, and a configuration for SKRL. So here we define how we want to use PPO. Yeah, there are some values for now. You can keep them like this, but if you want to know more about them, we can talk later. But the idea is, yeah, for now, like if you want to understand them, we can discuss them. And then here in the post tracking M, you have to define the environment. In this case, we are using direct RLM with only, yeah. It's quite long, the code, but you can check the main functions like prefix, apply action, get observations, get rewards, get dons to understand how it is. And then in the environment configuration, you can check here the class configuration for the parameters, so the simulation stuff. Also, there are some flags. So if you want to do jaw tracking, if you want to penalize something, etc. So you can check all of this. More or less, it is quite well described. The names are quite intuitive for the task. So yeah, you can just play around and let me know if you have some issues. And in order to use it, usually it's like I just create in the instructions are in the repo, but at the end you will end up with some code, some folder like this, like .vs code, and then there is a launch.json, and here you can create the task descriptions. So for example, I want to train the position tracking with PPO, and here you can include the arguments that you will pass to the file. So in this case, I want to train RL velocity. This is the environments, how many frames I want to train. So for example, usually you will need 20 million or 10 million to do something good. And then headless basically means that when you run it, a window doesn't pop up, so this is speed ups a lot. And this is the name of the running file in weights and biases. And then once you have this, it's quite easy because you can just go to any repository, like any file, sorry, and then here top right, there is the debug py command using some launch config, and then you can just click the title that you want, in this case, the training position tracking, and then it directly knows the file to run, which is this train.py, and it also knows the arguments. And to also do that, you need to create this task description. So that happens I will show you here. In the init.py, you need to call this team.register. So in this case, you can see that I am calling this one. And it basically tells it the program that you will use this configuration function, which is defined in the configuration. Like if you do Control C, and then here Control F, you will see the function. And then it also defines the entry for SKRL. In this case, there is only one, but in the future, there might be also some others. So I think this is all. If you have some questions, let me know. Now it is training, and then we should be able to see the new training coming up here.